Welcome back. Today, we join a craftsman surviving on the frozen surface of a remote lake. Searing meat directly over the ice requires a contained heat source, preventing the foundation from melting beneath the fire. This exposed expanse offers no natural shelter. The first priority is a windbreak, built from the terrain itself. Extracting structural blocks from a frozen lake is a calculated process. The clear, dark ice indicates deep, solid freezing capable of bearing immense weight. Using a manual auger, he creates pilot holes to weaken the surface tension. A heavy spud bar then shears the ice along stress lines, freeing large sections. Water expansion makes this ice exceptionally dense, turning each block into a formidable building material. Transporting them on a sled distributes the heavy load.
Hey!
Hours of heavy extraction drain core body heat rapidly. Maintaining a steady caloric intake is not a luxury, but a mechanical requirement in sub-zero temperatures. A hot meal restores energy reserves before the construction begins. The dark metal pan absorbs radiant heat efficiently, boiling water in the bitter cold. As the trench deepens, the work shifts from surface extraction to heavy lifting. Removing the slush is a critical step. If left in the channel, it quickly refreezes, fusing the blocks back to the lake bed. Lifting these massive sections requires leverage and careful balance. Pure ice lacks the friction of stone or timber, making every hoist unstable. The sheer mass of the stacked blocks absorbs and deflects the wind, creating a microclimate on the leeward side. Survival in this environment is about manipulating the elements to your advantage. Long timbers are laid across the walls to support a makeshift roof. The structural integrity of an ice shelter relies on eliminating drafts. Loose snow acts as a natural mortar. When packed into the joints, it sinters, welding the individual blocks into a single, windproof shell. Inside, a compact wood stove changes the dynamic entirely. The thick ice walls act as a massive thermal barrier, capturing heat from the metal. This trapped warmth allows the builder to rest and recover without losing thermal momentum. The open lake provides raw materials, but the surrounding timberline offers long-term shelter and sustenance. Moving off the ice, the builder harvests small-diameter wood for fuel. The nearby stream yields fresh protein, essential for enduring the extended winter nights. By afternoon, a lightweight transparent dome replaces the heavy ice structure. Setting up on snow requires a solid thermal foundation. Pine branches laid across the floor create an insulating dead air space, preventing the frozen ground from sapping heat. Exhausting combustion gases safely is vital for enclosed spaces. The tall chimney pipe ensures a strong draft, drawing fresh air into the firebox while venting smoke outside the breathable membrane. Nightfall drops ambient temperatures rapidly. The transparent walls offer minimal thermal resistance, making the active stove the sole barrier against freezing. The thin metal heats up instantly, radiating intense warmth into the dome. The fire does the heavy lifting. fast-moving mountain streams resist freezing, providing access to aquatic life even in deep winter. Catching fish by hand requires patience and an understanding of the current. Trout conserve energy by holding in quiet eddies behind large stones. Moving slowly prevents casting shadows that would startle them into deeper water. It is a harsh, immediate exchange of calories. Small fireboxes demand constant attention, requiring regular feeding to maintain a stable cooking temperature. Cast iron retains and distributes heat evenly, preventing delicate fish from burning on the intense metal surface. Preparing a hot meal with fresh ingredients elevates the survival experience. A sharp knife and precise cuts turn raw forage into proper sustenance. It is a careful routine that brings order to an unpredictable landscape. The next phase demands permanence. A lasting structure begins with a robust foundation. Notching the horizontal beams locks the wooden joints securely, transferring the heavy downward load directly into the vertical posts. Gravity holds the frame together. A layer of foil is laid over the platform, reflecting heat and protecting the timber base from stray embers. Managing hydration and body heat is a continuous battle. Boiling water provides internal warmth to sustain the manual labor ahead. With the base established, vertical framing dictates the footprint of the cabin. Precision matters. Poorly cut joints will shift under the eventual weight of snow and stone. Driving stakes into the frozen ground anchors the lower sill plates firmly. Every cross brace and rafter adds necessary rigidity against lateral wind forces. The builder checks alignment constantly, letting the natural timber guide the design. The steep pitch of the A-frame roof is engineered to shed heavy snowfall automatically. Slender saplings act as structural ribs, spaced closely enough to support outer cladding without adding unnecessary bulk. A secure horizontal tie beam locks the outward thrust of the angled rafters. Flat stones gathered from the stream bank form a durable foundation half-wall. Without modern cement, a thick mortar of local clay and soil fills the voids. As this mud dries, it hardens into a dense, wind-blocking masonry joint. Straight wooden poles fill the upper gables. The stacked timber encloses the space rapidly, transforming the bare frame into a solid, protected room. Raw timber walls leak air heavily. Green moss acts as a traditional chinking compound, swelling with moisture to seal cracks tightly against harsh winter drafts. A modern vapor barrier guarantees a completely waterproof canopy. Covering this membrane with more moss camouflages the structure, bridging the gap between primitive techniques and modern reliability. The interior floor is paved with cross-cut timber rounds. This end grain orientation stands up to heavy foot traffic while elevating the living surface away from the cold, damp earth beneath. The cabin is fully formed. The final addition pushes beyond mere survival. A heavy cast iron bathtub is seated on a sturdy log cradle designed to bear the immense weight of water and an occupant. Dry stacking a stone perimeter around the base serves a specific thermodynamic purpose. The dense rock mass absorbs heat from a fire, safely radiating warmth against the metal hull to heat the bathwater steadily. The cabin is tightly sealed and drawing heat efficiently. Outside, the fire pit roars beneath the iron tub. The transition from freezing air to scalding water requires meticulous timing. The thermal shock is sudden, but the thick iron basin retains its heat long into the twilight. A final meal prepared over the remaining coals marks the completion of the build. In the end, structure, landscape, and daily routine operate as one system. What began as an empty frozen bank is now a self-sustaining refuge. The craftsman leaves behind a permanent sanctuary built to endure.